Okay, good afternoon, all.
Good afternoon, sir.
Afternoon.
Good afternoon, sir.
Good afternoon. Okay, 25 members joined, 26. Manoj, I4. Ritvik, Pujita, they're joining. Okay, thank you for joining. There are 32 members now. $33. Okay, so I will start my class now. So today we're going to see the solar cell materials. Can you see? Somebody respond?
Yes, sir.
Yes, sir.
Okay, I'll share one of the material and I'll be talking about that. So can all of you see the material that is present here? Energy gap of solar cell materials.
Yes, sir.
Okay, now let me explain what is the requirement for this solar cell materials. One of the major requirement for solar materials is energy gap. The energy gap of the material must be suitable. Somebody is using annotation, please use eraser and remove the annotation. Hello? 219.
Sir.
Yeah, are you using annotation?
No, sir.
Who is writing here? Don't write anything, don't use any annotations here. Okay?
Okay, sir.
Okay, so there is a silicon material is there, and which is having energy gap of 1.11, and cadmium sulfate is there, and which is having 2.42 as the energy gap. Now, solar cell materials, the materials that are supposed to be taken care of must be having a particular character. That is, the energy gap of the material must be suitable to the light. What is the meaning of this? The meaning of this is there is light which is going to fall on the solar cell. So let us say this is a solar cell. So this light is going to fall on the solar cell. Solar cell is supposed to absorb the energy. This material which is supposed to be absorbing the light must have an energy gap which is suitable for the light. Suitable for the light. If the light is having a particular energy state, energy in the sense they have their own wavelength values, and it is going to be used here for the energy gap. The why it is having this peculiar thing. The energy gap must be suitable to the light. See here, if I have two energy states, which is the highest valency band energy and the lowest conduction band energy, then the electron must be moving from one to another place, in the sense from valency band to the conduction band. Now here it requires exactly the energy which is equal to the energy gap that is present over there. If the light which is used is not having this energy, that is energy gap, then those things, that light is not going to create electron and holes. They cannot create electrons and holes. So if they are there, then automatically if the energy of the light is sufficient enough, then only then they will be able to create electrons and holes in p-type material as well as n-type materials. So this is the requirement for the solar cell materials. Now therefore the materials that you see here, that those are the materials, silicon, cadmium sulfate, gallium arsenide, all the remaining things. There are different materials used for creating solar cells. At the same time, they are having different energy states also. As you can see here, just a minute. See, as you can see here, this is the one, different energy gaps are there. Different energy gaps give us different, they will be absorbing different lights. See here, this is going to be having a energy gap of 2.42, means it is having a energy gap, then automatically that is going to be given with a value of h nu per a light. Now this h nu is nothing but hc by lambda. It will have a specific value of wavelength lambda. For a specific value of lambda, that is going to be sufficiently having an energy level of the energy gap. That is the prime requirement for this solar cell to act. Otherwise, అంటే ఎలా చెప్పాలంటే light will have certain wavelength, lambda ఉంటుంది. So this wavelength అది ఎంత ఉండాలి అని అంటే ఈ energy gap కి సరిపోయేంత ఉంటేనే then only then the solar cell will absorb the light. Otherwise it will not. Now so write down all these energy gaps, okay, or take a snapshot of this one which is present over here. Okay, now so these are the requirements for a solar cell materials, right? That ends our solar cell. Okay, is it okay? Is it audible to you, all of you?
Yes, sir.
Okay. So
Sir,
this is how the solar cell. నిన్న మనం నేర్చుకున్నాం ఏం నేర్చుకున్నాము? What is the solar cell? What is the definition of solar cell? And what is the construction of solar cell? And what is the working principle of solar cell? And today we have seen what are the materials which are required, which are having certain energy gaps. So that ends your solar cell cell materials and this is topic. Okay, I'm removing this energy gap of solar cell materials. Right. So now we're going to start another topic for us, that is fourth unit. I'm sharing now solar lasers. Now write down what is this laser is a topic which is present in fourth unit. Okay, fourth unit. Prathvik, again admit. Can you see this lasers?
Yes, sir.
Okay. Now, lasers. Today, I'm going to deal with what is a laser and what are the prime important topics that are supposed to be understood before we understand the laser itself. Laser, okay, let me ask you one thing. That is unit 1, unit 2, unit 3. All materials are with you?
Sir.
Emma?
Yes, sir.
sir.
Okay.
Yes, sir.
So, unit 1, unit 2, unit
Yes,
3,
sir.
all 3 materials are with you?
Yes, sir.
Okay. Now,
Yes,
this
sir.
picture that I showed you, can you download this material that I'm sharing?
No, sir.
I will share this material in the WhatsApp group. Okay?
Okay, sir.
Okay, sir.
In WhatsApp group now?
Sir?
Okay. I'll shall I share it now?
Yes, sir.
Okay.
Screenshot is possible, sir.
No. I'll share the PDF itself. Okay. It is there in my.
Yes.
Yes, sir.
Okay, sir.
Okay, it is there in the WhatsApp group. I mean WhatsApp group, but how to share this? Okay, I just shared it.
Yes, sir.
Yes, sir.
Okay,
Yes, sir. Yes, sir.
okay. So, where are we? Can you see me?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Okay, gallery view, speakers view. Okay, now 211, don't talk. Make it mute. Okay, can you see this file which I shared with you now?
Yes, sir.
Yes. Okay, right. So I don't know where I am. I cannot see myself. Okay. Right. So if you carefully look at this file that is present over here, laser is an acronym, meaning that each and every letter which is present here has an extension. So I'll write this laser in this manner. L-A-S-E-R. L stands for light. A stands for amplification. S stands for stimulated. E stands for emission. R stands for radiation. So laser is an acronym which is nothing but light amplification by stimulated emission of radiation. Stimulated emission of radiation. So laser is an extension of light. It is not a simply light, but it is something more than light. So light, which is general light, is taken and it is being amplified, and by using a process known as stimulated emission, by the process known as stimulated emission. So by using this process, what we get output that we have is nothing but radiation. Radiation. See, there are three types of heat transfers that occur, which are nothing but, one of them is known as conduction. Another second one is known as convection. The third one is known as radiation. What I will repeat. There are three types of heat transfer that can occur. One of them is conduction. What is the meaning of conduction? Heat will be transferred from one point to another point by means of movement of there is no movement of particles. Just like if I take a small rod and if I heat that rod at one end, if I heat that rod at one end, the other end will also be heated up. But there is no transfer of any particles in that particular rod, but the heat is being transferred from one point to another point. That is known as conduction. The second process that is the second process in which heat can be transferred is by means of convection. Convection is a process where the heat transfer it will occur by means of movement of particles from one point to another point. The best example for this convection is nothing but heating of liquids. Namely, just simply you can take water. If I boil water, the lower part of the tumbler that we have taken or the vessel that we have taken is being heated up generally. Now once it is heated up at the bottom, it is where the lower part of the water which is present over there is heated up first. And now this heated up water the water particles will start moving up. Now the second layer goes down and it is being heated, and this process continues, and the second layer, when it is heated, it goes to the top. So in this manner, the heat is transferred from one point to another point by means of movement of particles. In the first case and the second case, that is the conduction as well as convection, medium is required. Medium in the sense, in a particular rod is a medium where the particles are attached to one another. And the second case, that is convection, also the water molecules is a medium, water is a medium. But the third way of movement of energy from one point to another point is nothing but radiation. Radiation is nothing but light which is coming from sun to earth is nothing but radiation. Radiation requires no medium. First two cases, there is a requirement of medium. The third case that I'm talking about, which is nothing but radiation, does not require any medium. So this is also movement of energy, heat energy from one place to another place without any medium here. So that is the explanation about radiation. So now it means the laser that is present that we are going to talk about, it can be transferred to another areas where there is no medium is present. In the sense, they can be sent onto the space. In the sense, the communication in these days is done by using lasers only, because it is having high accuracy. I'll be talking about the characteristics of lasers later. In the characteristics of lasers, we will be talking about the main characteristics that are present in laser, which is directionality, monochromatic character, less divergence, coherence character. All these things are going to be given, are present for lasers, which are giving us a very prominent role that can be played by lasers. Now, so now we are talking about lasers. Now, before lasers, is there any way through which we used to have a radiation, amplification is done? Yes, there is a particular process known as MESUS, microwave amplification is done, and in which also we have come across radiation as an output. So that is known as MESUR, 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 in which the M stands for microwave amplification by means of stimulated emission. Okay, now here we are talking about optical, in the sense light is being used, whereas in the case of MESUR, microwaves are used. So laser is an extension to MESUR. This particular thing, the amplification by means of stimulated emission, was explained by Einstein in 1916 itself. 1916 itself. Remember, 1916 itself. But the invention of laser was done in the year 1960. There is a vast difference between these 2 years. Einstein was proposed so many theories regarding the amplification of any waves, any type of waves by means of stimulated emission. But it was not implemented, or it was not, there is no laser even for after 50 years. More than 50 years it took to create laser as an output, laser as our light. So here, what is exactly this laser is all about? Now, before we want to know what exactly are the characteristics of lasers, laser ante enti, danikuన్న లక్షణాలు ఏంటి, ఇవన్నీ మనం తెలుసుకోబోయే ముందు we need to know certain terminology in order to understand lasers. The main terminology that we need to understand are nothing but they are written here: absorption. See here carefully. Just a minute. Absorption, spontaneous emission, and stimulated emission. So these are the three things that we need to understand well. Absorption, spontaneous emission, and stimulated emission. Now, let us see. Somebody is, okay. Don't use your annotations. I'll be using annotations only. Okay, right. So here we are going to see what is absorption. Oh God. Okay. I hope this only one page is being shared. Okay. So annotations are supposed to be removed before we proceed. Right. Okay. See this absorption. So absorption is a process in which the absorption of energy occurs. So I'll be giving you from step to step, one by one. Imagine if there are two energy states, E1, let us say those energy states are E1 and E2. Two energy states are there. What are these energy states for? Denikulla energy states for an atom. For an atom, let us say the atom A. Okay, atom A is having an energy, two energy states, E1 and E2. Now, if this atom is provided with some energy, let us say h nu is the energy that is provided to the atom. That is, this is given with a photon of energy h nu. What is h nu? Energy of photon. So, if it is given with an energy h nu, then it must be equal to the difference between the energy states, that is E2 minus E1. If this, which is the energy that is given to the atom A, is sufficiently enough, means if it is equal to the difference between the energy states, then it will be able to absorb the energy, and this atom is going to be excited to the higher energy states. Higher energy states, in the sense the atom is having an energy now, higher or excited energy. You should understand this as incident photon, and now this atom is holding this. Let us say if this is A, atom A, this is treated as A star. It means A given with or provided with energy h nu, it is going to make the A to be excited. A star represents excited state of an atom. Excited state of an atom. Now, what exactly this means? Now, జాగ్రత్తగా అర్థం చేసుకోవాల్సింది ఏంటి అంటే, atoms are where these atoms are. For example, I want to have a laser cover. In order to have laser, this laser must be produced from a material. Material means, let us say there is a small material, a material of type, a small rod, something like this, a small chalk piece. It is made up of some material. The first laser actually was made up of ruby rod, which is almost like this. Okay, ruby rod is a type of material. Now, this material contains atoms or molecules or ions. Now, I'm talking about those materials. This A may represent either an atom or a molecule or an ion. Okay, A represents any of these things which is present in a material. Now, this and these atoms which are present in a material, when the material is provided with energy, then though that energy is absorbed by the atoms in the material, and it is now in the excited state. మనం అర్థం చేసుకోవాల్సింది ఏంటంటే ఏ అనే ఆటం ఎక్కడికి కదలదమ్మా, అది ఎనర్జీని అబ్జార్బ్ చేసుకొని హైయర్ ఎనర్జీని కలిగి ఉంటుంది. It is absorbing the energy. Now it contains higher energy. That is what we should understand. Now this process of absorbing the energy from the photon and attaining higher energy states is known as absorption. Process. If you can understand, read this carefully from the chapter which I shared with you, the paragraph which I shared with you, you understand this better. That is, before, this is after. Before absorbing the incident photon, after absorbing the incident photon. This process is known as absorption. Absorption has some other names also, which is also known as induced absorption or stimulated absorption. What is the meaning of stimulated absorption or induced absorption? Well, the meaning is nothing but it is being forced to absorb the energy. Forced to, stimulated or induced. దాన్ని ఫోర్స్ చేసి దాన్ని అబ్జార్బ్ చేసుకునేటట్లు చేశారు అని అర్థం అన్నమాట. So, or simply it can be termed as absorption. Okay, so is that clear? Emma, is this clear? Absorption.
Yes, sir.
Okay, now,
Yes, sir.
right, so this process is known as absorption. Let me explain or give you a small definition about absorption. Absorption of energy from a photon or by any other means. Absorption of energy by an atom which is in the lower energy state and attaining the higher energy is known as absorption process. Okay. Now, did you note down these things?
Sir.
Material lo kuda untundi, material lo chusturu gani. Right. The second process that we have here is known as spontaneous emission. Spontaneous emission. Okay, can you see this spontaneous emission?
Yes, sir.
Era నిద్రపోతున్నావా ఏంది? Right, spontaneous emission. Now, absorption జరిగింది ఇందాక. Absorption అయిన తర్వాత the atom is present in the excited state. Now, ఆ స్టేట్ ని మళ్ళీ మనం తీసుకుందాం. That is, there are two energy states are there. One of them is E1, another state is E2. The atom is present in the excited state. What shall I call this atom as? A star. Let us say A star is the excited atom. Now, we know very well that atoms cannot stay in the excited state for a long time. Why? They are unstable in the excited states. Because they are unstable in the excited states, they want to lose energy and they want to come down to the lowest possible energy state and they want to stay there. This is a common for either an atom or a molecule or an ion. Any of these things, they will always want to be stable by means of occupying the lowest energy state. Okay, so how much time it is going to be present in the excited state is in the order of 10 to the power of 7 to minus 7 to 10 to the power of minus 8 seconds. So, మనం జాగ్రత్తగా గమనిస్తే the higher energy state is being observed by an atom only for very fraction of seconds. ఒక సెకండ్ అంటేనే తక్కువ అమ్మా. Just imagine 10 to the power of -7 to 10 to the power of -8 seconds. What is the 10 to the power of 7? 1 crore. Okay, so if you divide 1 second into 1 crore times, that is nothing but 10 to the power of -7. So very short-lived in the excited state. If it is short-lived in the excited state, what it does is nothing but it wants to give away its energy. So now if you see carefully, this atom in the excited state, they want to lose their energy and come down to the lower energy states. By losing energy, I mean to say, by losing the exact amount of energy, which is h nu, which is again equal to the difference between the energy states, that is E2 minus E1. So this which is present over here is known as emitted photon. Emitted photon. Emitted photon. So here, why it emitted photon? Because it is unstable. The atom is unstable in the excited state. It means the excited atom has come down to the ground state, and by losing its energy, h nu. This is the representation of this process. Now, why it is called as spontaneous emission is because it cannot stay in the higher energy states for a long time, and it loses spontaneously. That is why this process is known as spontaneous emission. Spontaneous emission process. మనం ఒక రకంగా చెప్పుకుందాం అమ్మా. మనం ఫర్ ఎగ్జాంపుల్ ఎవరైనా ఇంటికి క్లాస్ కి ఒక చిన్న టాయ్ తెచ్చి ఆ టాయ్ ని మన మీద పడేశారనుకో, ఆ టాయ్ ఫర్ ఎగ్జాంపుల్ అదేమన్నా చిన్న బల్లి లాంటిదో లేకపోతే టాయ్ రబ్బరు పాము లాంటిదో అనుకోండి, మనం ఏం చేస్తాము, మనకు ఒరిజినాలిటీ నిజం తెలియదు కాబట్టి స్పాంటేనియస్ ఏం చేస్తాం, మన మీద వాడు ఇసిరేయంగానే దాన్ని తీసి ఇంకో చోటకి ఇసిరేస్తాం కదమ్మా. సో సిమిలర్లీ హియర్ spontaneously the energy is released. One more thing that we need to understand here is when the energy is emitted spontaneously, it is emitted in random directions. Random direction. నేను ఇందాక మనం పెట్టినప్పుడు మనం డైరెక్ట్ ఇలా మనం ఒక డైరెక్షన్ ఇచ్చాం అబ్జార్ప్షన్ లో, వేరే ఇక్కడ అయితే ఏ డైరెక్షన్ ఇవ్వచ్చు, ఎనీ డైరెక్షన్ ఫర్ ది ఎమిటెడ్ ఫోటాన్, because it is emitted in random direction. Random direction in the sense it is emitted in any direction which nobody knows. దానికి కూడా తెలియదు ఏ డైరెక్షన్ లో ఎనర్జీ బయటకు వస్తుంది అనేది తెలియదు. Now when it is being randomly coming out, so what is going to happen? If you carefully see the chaotic representation which is present over here, చూడమ్మా, which is present over here, ఇక్కడ ఉంది కదమ్మా, this that is present over here, it is a chaotic representation of different waves. ఇక్కడ మనకి different waves ఉన్నాయి. ఈ waves అన్ని కూడా మనకి different దీన్ని ఇస్తున్నాయి. So the result of this wave front is nothing but a disturbed wave. A disturbed wave. So it means it is going to have a different way of representation of the wave. So ఈ వేవ్ ని మనం డిస్టర్బ్డ్ వేవ్ అంటాం. ఇప్పుడు ఒక రకంగా చెప్పుకోవాలి అని అంటే, మనకి ఏదైనా మ్యూజికల్ ఇన్స్ట్రుమెంట్ ప్లే చేశారనుకోండి, మనకి చాలా హ్యాపీగా ఉంటుంది. వేరాస్ ఇఫ్ వి యూజ్ ఒక చిన్న గ్లాస్ తీసుకొని ఒక ప్లేట్ మీద పెట్టి రాసామనుకోండి, లేకపోతే ఏదైనా స్టోన్ మీద పెట్టి అన్నాం అనుకోండి, ఎలాంటి సౌండ్ వస్తుందమ్మా? chaotic in the sense very disturbing. So తలకాయ నొప్పి వస్తుందిరా అని చెప్పి అనుకోవచ్చు. So that is known as chaotic. This which is present over here is going to have such behavior. So this is what is happening in the case of spontaneous emission. Manaki, how many such processes will occur in a material? I'm actually talking about one atom, but there are innumerable number of atoms are present in a material. Material చూసుకుంటే చాలా atoms ఉంటాయి. Energy is provided in the form of either light or in the form of a heat or in the form of a chemical reaction. That energy is being absorbed by the atoms or molecules or ions, and all of them they will be absorbing, and all of them they will be spontaneously could give their energy as an output. So the output is not going to be useful, is not going to be useful. So automatically it is going to be released in a different direction. So it is not useful for anybody. What is not useful? The spontaneously emitted light cannot be used to observe or obtain laser. Now, what is useful for obtaining laser? And that process is known as stimulated emission. What is it? Emma, spontaneous emission అర్థమైందా? Hello? 219?
Sir.
Emma, spontaneous emission అర్థమైందా?
Sir.
Emma,
Yes, sir.
అందరూ నిద్రపోతున్నారు.
Yes, sir.
Late,
Yes,
sir.
sir. On, sir.
Emma?
Late, sir. వింటున్నాం.
All right.
No, sir. Intunam, sir.
Okay. So this is what is spontaneous emission. So spontaneous emission process లో మనకి వచ్చినటువంటి లైట్ అనేది లేజర్ కి ఉపయోగపడదు. సో ఒకసారి మళ్ళీ చెప్తున్నాను స్పాంటేనియస్ ఎమిషన్ ఏంటో. ఎక్సైటెడ్ స్టేట్ లో ఉన్నటువంటి ఆటము ఎక్కువసేపు ఆ ఎక్సైటెడ్ స్టేట్ లో ఉన్న ఎనర్జీని హోల్డ్ చేయలేదు కాబట్టి it wants to lose its energy and come down to the energy states, lower energy state. Generally lowest energy state మనం ground state energy అంటాం. So once it is excited by means of absorption, excited అయినటువంటి దాన్ని మనం తీసుకున్నప్పుడు it is going to come down by means of emitting a photon spontaneously. The energy which is released is equal to the difference between the energy states, E2 minus E1. E2 minus E1. So this a process can be represented in this manner, which is excited atom A is going to come down to the energy state, ground state, or the lowest energy state by releasing a photon. A photon. Now, the next process that we have here is known as stimulated emission. Stimulated emission. If you carefully observe the spontaneous emission and stimulated emission, what is common in both these things is the atom before the emission, the atom is present in the excited state. The atom is present in the excited state. That is energy state, higher energy state, E2. If I take only two energy states. Atom ki runde energy states untayama? No, there may be more than two, maybe 3, maybe 5, maybe 7, maybe any number of energy states can be present for an atom or molecule or ion. Now we are considering only two energy states. Now let me explain what is stimulated emission and what is the difference between spontaneous emission and stimulated emission. Now here if you carefully observe, just a minute. Yeah, this is the situation before the emission that is known as stimulated emission. Now, here in this state, when the atom, the excited atom A star is present in the excited state, by any means, if I provide a photon of energy h nu, which is equal to E2 minus E1 to the atom which is already in the excited state. Already in the excited state. That means the atom A star is provided with energy h nu. Again, A star antene energy తీసుకునుంది already. మళ్ళీ మనం ఏం చేస్తున్నాము? మళ్ళీ ఎనర్జీ ఇస్తున్నాం. Again, energy is given to the atom which is present in the excited state. What is going to happen now? Here, as soon as the atom is going to receive second photon, it cannot hold both the photons. It cannot hold both the photons. Now, this atom releases energy. Both the photons are being released, which are h nu and h nu. Both the photons are released, and it is going to come down to the energy state, ground state. Ground state energy, that is this A. Now, it means that it's something like this. ఒక రకంగా ఎగ్జాంపుల్ చెప్పుకుందాం. ఒకడు ఆల్రెడీ ఒక బిర్యానీ ప్యాకెట్ మొత్తం తిన్నాడు అనుకోండి. ఇప్పుడు రెండో వాడు వచ్చి ఏం చేస్తున్నాడంటే రెండో బిర్యానీ ప్యాకెట్ ఇచ్చాడు. అది కూడా నేను తినలేనురా అన్నా సరే మళ్ళీ బాగా కుక్కాడు అనుకో, ఏం జరిగిద్ది? ఏమ్మా, రెండు లోపల నుంచి బయటకు వస్తాయి, అంతేనా? సో ఇక్కడ కూడా అలాంటిదే జరుగుతుంది, జాగ్రత్తగా చూడండి. The atom which is not able to be present in the excited state, excited లో ఉండటమే దానికి కష్టం. 10 to the power of -7 to -8 seconds లో అది బయట వదిలేస్తుంది. ఈ మధ్యలోనే ఏం చేశారు అని అంటే, దే ఆర్ గివెన్ విత్ సమ్ మోర్ ఎనర్జీ, ఇంకా కొద్దిగా ఎనర్జీ ఇచ్చారు. ఇప్పుడు ఏమైంది? ఇట్ కెన్ నాట్ హోల్డ్ ఎనీ మోర్, దెన్ ది ఎనర్జీ ఇస్ బీయింగ్ రిలీజ్డ్ అండ్ దే ఆర్ గోయింగ్ టు బి రిలీజ్డ్ ఇన్ దిస్ మేనర్. మనకు వచ్చిన అడ్వాంటేజ్ ఏంటి? Stimulated, this process is known as stimulated emission. Why it is called as stimulated emission? Excited state లో ఉన్నటువంటి atom ని forceful గా మనము ఎనర్జీ రిలీజ్ చేసేటట్టు చేశాం. That is why it is called as stimulated. దాన్ని ఫోర్స్ చేసాం మనం బయటికి వచ్చేటట్టు చేయటం. So it is called as stimulated emission. Now, the incident photon here and the emitted photon here, they are in the same direction. ఏం చెప్తున్నానమ్మా, జాగ్రత్తగా వినండి. The incident photon here and the emitted photons from the atoms here, they are in the same direction. They are in the same direction. One more thing, both these photons are having same phase relation. Same phase relation means they are being amplified. When two or more waves are having same amplitude or same phase, the resultant is going to be increased amplitude. See here carefully. ikkada meeku kanamadutund chudandamma. These are all the coherent radiations, means their waves, just a minute, these are called coherent wave radiations. This or this or this, ee moodu kuda they are in phase ani cheppochu. When they are in phase, the resultant is in this manner. The resultant is in this manner. It means that the outcome that is coming out by means of stimulated emission is having increased amplitude. If you carefully observe the previous case, in the previous case what we could see is not like this. Is not like this. In the case of spontaneous emission, what we have seen is a chaotic representation, chaotic notation. ఇక్కడ జాగ్రత్తగా C లో చూడండి 1 2 3 and 4 రెండు అన్ని కలిపితే a chaotic representation, whereas now if you see carefully by means of stimulated emission, the waves are being amplified. That is the advantage that we have here in the case of stimulated emission. So stimulated emission is a process in which the resultant amplitude of the waves, that is the resultant amplitude of the light which is coming out, photons ante light e kadamma, so the light which is coming out is having amplified light. In a sense, what is the square of an amplitude? Intensity. It means the intensity of the light is being increased. One of the character that is exhibited by laser is a very high intense beam of light. So it means that stimulated emission is the process by means of which laser can be obtained. మనకి ఇక్కడ ఒక విషయం గుర్తుపెట్టుకోవాలమ్మా, అదేంటంటే stimulated emission itself is not laser. Stimulated emission is going to lead to obtain laser. Laser రావటానికి stimulated emission వచ్చిన తర్వాత జరిగింది. What is going laser ఎలా వస్తుంది after stimulated emission అనేది another process. దాన్ని మనం చూసుకోవాలి, దానికి ఒక ప్రాసెస్ కావాలి which is known as optical feedback. అదేంటో మనం నెక్స్ట్ క్లాస్ లో చెప్పుకుందాం. There are three processes that I explained today, which are nothing but spontaneous emission, absorption, spontaneous emission, and stimulated emission. Now, what exactly is going to be the difference between spontaneous emission and stimulated emission? ఈ రెండిటికి ఉన్న differences ఇక్కడ మీకు ఎక్స్ప్లెయిన్ చేశాను చూడండి. Spontaneous emission is a process by means of which the transition occurs from higher energy to the lower energy, and the no incident photon is required. Whereas in the case of stimulated emission, in this process what we require is an incident photon. Incident photon అనేది మనకి కావాల్సి వస్తుంది. ఇక్కడ జాగ్రత్తగా చూస్తే ఇన్సిడెంట్ ఫోటాన్ అనేది మనకు కావాల్సి వస్తుంది. CK here we require photons whose energy is difference is in 2 energy levels is required. Now in the case of spontaneous emission, single photon is emitted. In the case of stimulated emission, 2 photons are released. And in the case of spontaneous emission, the emitted light is less amplified. And in the case of stimulated emission, it is more amplified. Okay, I hope the time is getting over and you go through these differences, that is spontaneous and stimulated emission. Okay, unmute yourself, all of you, and what is writing here? Okay, is that clear? The process is clear to you? Absorption, spontaneous emission, stimulated emission. Emma, అర్థమైందా? మాట్లాడలేదు. I unmuted all of you. No? Okay, this ends today's class. Tomorrow we will see the remaining topics in the okay. Hello.
Unmute, sir.
Okay, bye.
Nalakshman.
Okay, we'll meet in WhatsApp. Right, bye. I'm ending the meeting today now. Thank you.
Okay, sir. Okay, sir.